My name is John Abelson. I'm a materials science engineer, and I'm a professor in the Department of Materials Science here at the University of Illinois. We are engaged in looking at how you make materials, what the properties of the materials are, and how you use those properties to make real things that are part of science, technology, and life. As professors, we all have three jobs, and we're carrying them out virtually all the time. One is to teach. Another pursuit is to do leading-edge research, to come up with new things, publish them, advance the state of the art in the knowledge. And our third job is called service, which is to contribute to the scientific community, the local community, the university community. I, as a professor, have to think of important new work to do and actually raise funding. This comes from a number of sources, including the National Science Foundation. So that phase of my work concerns making thin films, coatings, that are sometimes extremely thin, literally only 10 atoms thick at times, a coating that will not melt, just absolutely will not melt. That allows you to do things that weren't possible before. So this is the apparatus where we load the piece we're going to coat. I really got my start at a small high school, so I had wonderful science teachers in mathematics, biology, chemistry, physics. I went on to Yale University and I did a degree in engineering and applied science. One of my early experiences, I worked at the National Renewable Energy Laboratory. Myself and another scientist actually put together a laboratory to make solar cells for direct conversion of sunlight to electricity. So the solar cell actually consists of a piece of glass which will eventually be mounted in a frame, and the sunlight will enter through the glass. So it's a coating. On the back side of the glass is the photovoltaic cell. We're already building buildings where the exterior walls are largely made of glass. We're already paying for that glass to be coated for purposes of light and heat control. Suppose now I just replace some of the coatings we're already paying for with new coatings which are solar converters. This is called building integrated solar cells. And the cost structure of that looks very favorable because you're not creating entirely separate solar panels, which you have to mount somewhere and wire. They're just integrated with the very shell of the building. But how can we develop things that allow people to have better lives, which are not too costly for the planet? It's something that's critically important, and it's something where we play a very important role.